Okay, let's look into the stator motor connections. So stator windings can be connected Y or delta. The connection point of the windings are called T-leads, and they're typically brought out to the terminal blocks of the motor, and that's where we do our electrical connection. Now, some motors that are intended to operate at a single voltage and at a single speed contain 3 T-leads. You'll only see a T1, 2, and 3. And the connections internal will be like below, where we'll have a delta with a T1, T2, T3 coming out, or we'll have a Y connection. And those are very basic motors and actually uncommon. Most motors are dual voltage. Okay, so one of the types of dual voltages is this one listed here at 240, 480. Sometimes you'll see 230 volt, 460 volt. Okay. These motors, they contain 2 separate windings per phase. The logic behind it is it's cheaper to manufacture one motor to do 2 voltages than 2 separate motors to do those specific voltages. So it gives a little bit of a versatility to the motor manufacturers. The most common dual voltage motor is the 9 lead. It'll have 9 T-leads in it. Okay. Now, 9 lead motors will always have one set of leads connected internally, whether it be a Y or a delta connection. And we're going to have a look at those. Here we have a nameplate for a dual voltage 3 horsepower motor. Notice at the volts here, it says 230 volts, 460. So those are the 2 voltages that we can connect this motor up to. And this is a 9 lead motor, so we'll have to series or parallel those leads, which we're going to look at in a second. Here we have a wiring diagram for a Y-connected 9-lead motor. What we have to pay attention to is how the numbers work, because we need to know how these numbers work so we can find out how we're going to make the connection. So we have wire number 1 up here, and it's going to be starting at the outer edge here. Now this is called a spiral method for numbering these leads. So the simple way to identify it, and if you're tested on this, it's good to know. We start off with number 1, and then we go in a counterclockwise rotation. Okay, the next outside one will always be number 2, and then the last outside terminal or T-lead will be 3, and then we go to the next one in that's opposite end of the coil for terminal 1. Now notice that on the coil, on this coil here, the number of the T-lead on the opposite end of this coil from a number 1 will always be a value of 3 higher. So 1 plus 3 is going to be 4. Okay, so we'll keep on with our spiral method. We carry on all the way through to the other end of the coil that T-lead 2 was connected to, and then we'll find number 5. Again, it's an increase on the opposite side of the coil by a factor of 3. So 2 plus 3 is 5. And then we'll continue with our spiral method in our counterclockwise to the next number is going to be 6. Okay, which again, 3 was the outside T-lead number, and then the same coil, the opposite end of the same coil, is going to go up by 3. So we're going to have 6. Now we keep our spiral going in further. Now the next one that's going to be in phase with our coil 1 and 4 is going to be our 7. And guess what? 4 plus 3 gives us 7. So that's going to be the 7 lead, the next one here. And then we spiral in. And we get to the next one, which is going to be 8, which is in phase. This coil here is in phase with our 2 and 5. they're pretty well wound around the same part of the motor. And then we keep spiraling in till we hit 9, and that's our final T lead. There is other ends of these coils. They're internally connected in the middle, and actually those would be 10 and 11 and 12 T leads if it was a 12 lead motor. We're going to look at it in a moment. So one more time. So when we want to start numbering these coils, we start at outside 1, and we go from 1 and we go counterclockwise to the next outside is going to be a 2, the next is going to be a 3, then we go in, it's going to be 4, then 5, then 6, then 7, 8, then 9. Pretty straightforward. Okay, so when we want to make a high voltage connection here, these coils are going to have a maximum voltage rating. So if we looked at that value, that 230 460 volt value we were looking at before, if we were to connect it up to the higher voltage, okay, well, let's say it was 480, a 480 240 volt motor. Okay, so if we had 480 connected to this motor, we're going to have our line voltage across this Y connected load, this motor load, which is actually a Y connected load. We're going to see 480 volts from L3 to L2 and L2 to L1 and L1 to L3. We're going to have the line voltage across those points is going to be, let's say, 480 volts, for example. Now that's going to make 277 volts across each of these phases. Okay, so that means half of that, half of 277 is going to be the voltage we're going to see across each of the coils in each phase, which is 138.5. Okay, so we're going to see a 138.5 across this guy and this guy. Now that's the high voltage connection. So when we do have our high voltage connection, we're going to connect our windings here in series. Okay, we're going to connect we're going to do a jumper between 4 and 7, 5 and 8, and 6 and 9. Now over here on the side, that's a terminal box diagram, or block diagram sometimes called. Okay, or connection diagram. Okay, most motors, all motors have, most motors have this type of connection diagram on it. So, and it'll indicate what jumpers to do what at what voltage. Okay, so right here, the diagram tells us we have to jumper 4 and 7, and then 8 and 5, and 6 and 9, which we did here, here, and here. Okay, and then 1, 2, and 3 goes out to our supply lines. Line 1, line 2, line 3, connect up to 1, 2, and 3. Now here we go. Here's actually that same nameplate, and over on the right side, we have our low voltage and high voltage connection. So here's the high voltage connection. It's exactly the same as the previous slide that we were looking at, where we had 4 and 7, 5 and 8, 6 and 9, and then we get 1, 2, and 3. They connect to the supply lines coming in. Every NEMA motor, actually, most motors in the world follow this type of convention for high voltage connecting and low voltage. Now, we're going to look at the low voltage in a minute. This is a pretty standard method of connecting them. You're going to see motors come from the manufacturer. They may have these type of ring fittings on them, and it's just a matter of getting a small little nut and bolt the ones together you need, tape them up, put a lot of rubber tape and electrical tape on these connections, because these ends are going to sit in this junction box here, and these motors vibrate. So the terminations or splices you made inside these box, they can actually rub into the side of the enclosure here and wear through your if it's just regular electrical tape, and cause a fault, and then cause a downtime because the motor will blow the fuses and fall out of service. So here we have a low voltage Y connection. if the Y connection motor is to operate in low voltage, the stator windings are connected in parallel, as shown here. So let me get my little magic pointer. Okay, so when we're talking about connecting in parallel, that means our 1 to 4 winding, it's going to go parallel with our 7 to star point. Our 2 to 5 is going to go in parallel to our 8 to star point. Our 3 to 6 is going to go in parallel to our 9 to star point. So you see our jumpers here. We're going to go 1 to 7, 3 to 9, 2 to 8, and then we're going to connect a secondary star point here. Yes, it's not connected to the star point that's already established. That's not necessary. These two parallel Y connections will function perfectly as is. Now if we have a look at the connection diagram here that's found on the side of the motors, it's showing us how to do those connections. We're doing 4, 5, and 6. We connect those all together into a new Y point or star point. We're going to jumper 3 to 9 and 2 to 8 and 1 to 7, and then our L1, 2, and 3 will tie into T1, T2, and T3 respectively. Now here we have the stator windings for a 9-lead delta. Okay, now how do we identify these guys? Well, we go and we kind of do the same circle method that we followed for the Y. Now this is a dual voltage delta also. As you can imagine, if we had 480 volts connected to here, we'd have to jumper these together if we had a high voltage and a low voltage, because each winding is going to have a lower voltage rating. So if it was a 480 240 volt motor, right, if we parallel these windings, we would put 240 volts across them. If we supplied 240 volts to the motor, if we series them up, we can apply 480 volts and still only have 240 volts across each winding. Now to do a low voltage connection, we parallel these, which gets a little confusing here. So what we're doing is this 1 to 4 winding, we're going to parallel it to this 7 to, well, that would be 10 down here. So we're going to parallel those. So to do that, we go 4 goes to 2, and then 1 is going to go to 7. Okay, and then the same thing over here on this 9, we'll call it 9 to 1 winding, it has to go parallel to this 6 and 3 winding here. Okay, so we're going to go 9 is going to connect to 3, and that 1 is going to connect to 6. So what we're doing is these windings getting paralleled with this one. This 7 to 2 is getting paralleled to the 1 to 4, and then guess what? The 2 and 5 and the 8 to 11 here, which would be 11, or 8 to 3, they're going to get paralleled. And then when we look at our connection diagram that's on the motor, it's telling us right away L1 is going to connect, our lines are going to 1, 2, and 3 are going to connect to 1, 2, and 3, but we're going to tie 1 to 7 to 6 together. We're going to tie 2, 8, and 4 together, and we're going to tie 3, 9, and 5 together. This is a standard. All NEMA motors and are going to connect in this methodology. So here we have a 12-lead dual voltage motor, often used for Y delta starting for large horsepower motors and such. These motors can be connected in a Y or a delta, and the connections are going to follow the 9-lead, except the difference between the 12-lead and the 9-lead for this Y, let's say, is the 10, 11, and 12 on the 9-lead are done internally, where this connection will be made by the person doing the installation. Now if we look at the 12-lead motor schematic here, we can use the same 12-lead connection or 12-lead motor for either a delta or a Y connection, which increases a little bit of versatility of the motor, but it's not really commonly used. Usually they're going to all be Y or all delta. But on this, if you have a look here, if my laser pointer is working. We have terminal 1, 4, 7, and 10 all in one phase. So we have terminal 1 on one end of the coil. Terminal 4 is going to be on the opposite end. The coil that's in that's parallel or in phase with that coil is going to be terminal 7 and terminal 10 here. Okay, so if we wanted to use the 12 lead motor here as a delta connection, just have a look. We can just rotate this 30 degrees and then go over to what our delta connection would look like here. So we'll be connecting again for a higher voltage connection. 4 and 7 gets connected together, but to make it a delta connection, we're going to connect 1 and 12. Okay, so we have terminal 12 down here, okay, which is in phase with the 3-6, okay, and the 3-6 coil and the T9-12 coil are in phase with each other. Now we're going to connect our T12 up to T1. What that's going to do is, that's going to create our connection for part of our delta connected motor here. So then the other end of T3, so at the other end, if these are seriesed up, the other end of the T12 9-6 series windings, the T3, we're going to connect up to T11. Okay, so basically we're going to follow this numbering convention here. If you had to label these, if you had these numbers and you wanted to identify which they were, let's say you only had T1 here, but you have this diagram, you start off with T1 and you do your circle method again, where you can go around to the next horizontal line of coils. And so you start off with 1, you do the circle method to 2, you go over to the next horizontal line of coils to the first terminal to 3, and you go to 4, and then circle past where you started to 5, and you can do a little bit of a circle method for finding out what label is for which terminal or T-lead. Six-lead motors, simple little guys. You can connect them in a Y or a delta. Again, not too common, but you may encounter them. You can use these for Y delta starting, where you can start in a Y and run in a delta. Why is that important? Well, I'll just run a quick example for you. If we had a 480 volt motor and it was running, let's say, 10 amps phase current, when it's connected as a delta, our line current is going to be 17.32 amps. Okay, so if we have it connected as a delta, our line current is going to be 17.32. Now if we reconnect the delta connected windings as a Y, well, what's going to happen? We have 480 volts. Our motor, our phases are going to see 277, root 3 less. So our current now, which used to be 10 amps for the phase, is dropped down by a factor of root 3, which is going to be 5.77 amps. So what's happened is our line current, if we start in a Y, will be, because the voltage across the coil is dropped to root 3 less, our phase current here is going to drop by root 3, but it's Y connected, so that's what our line current is going to be. So we've reduced our line current by a factor of 3 to 1/3, where it used to be 17.32. If you divide that by 3, you're going to get 5.77. Anyway, thank you very much.